Meet Kawasaki Corleo, a four-legged robot horse designed to carry people up to 100 kilometers per hour. No reins, no saddle, no engine noise, just cold precision and incredible balance. Corleo isn't a toy. It's built to handle uneven terrain, heavy loads, and human riders, with the same grace as a real animal. Its joints mimic muscle movement. Its sensors read the world in real time. And yes, it moves like a living thing. Kawasaki says it could be used for rescue, mobility, or even military support. But one thing's clear, this isn't just a machine, it's evolution, on 4 robotic legs. The future's coming so fast, we might soon be watching robots step into the ring instead of boxers. Unitree just announced the world's first robot vs. robot boxing match. Full-size humanoids, no wires, no humans inside. These machines will dodge, punch, recover, and fight autonomously using real-time AI. While it may seem like something out of science fiction, Unitree has announced that the first match is coming soon. Geoffrey Hinton is the man to thank for what we now call artificial intelligence. Dubbed the godfather of AI, he co-authored the neural networks technology that powers ChatGPT, Gemini, and others. He's not just an expert, he's an architect. Now he's warning us.
I think we're moving into a period when, for the first time ever, we may have things more intelligent than us.
Hinton believes that AI is already capable of understanding, making decisions, and in the near future, it could achieve self-awareness.
What we did was we designed the learning algorithm. That's a bit like designing the principle of evolution. But when this learning algorithm then interacts with data, it produces complicated neural networks that are good at doing things, but we don't really understand exactly how they do those things.
A small blue robot stumbles, falls, then gets up. Again and again. No human rushes in to help. No one tells it what to do next. It looks around, spots the ball, and runs. This isn't a Pixar short. It's DeepMind's latest experiment. Teaching robots to play football, one-on-one. But here's the twist. No one taught them how. The bots weren't programmed to dribble, pass, or score. They weren't shown footage or given rules. They were dropped into a simulation and given a goal, put the ball in the net. What happened next is pure self-learning. Millions of trial runs, falling, failing, adapting. Until one day, they started winning. They learned positioning, timing, angles, balance. They even developed strategy. Not by code, but by experience. Once trained in simulation, the same brain was moved into real-world robots, and it worked. Zero retraining. These aren't scripted machines, they're players, and they're learning entirely on their own. That's what Geoffrey Hinton is talking about.
I think in 5 years' time, it may well be able to reason better than us.
A single image, one reference performance, and suddenly your photo becomes an actor. DreamActor M1 is an AI that takes a still portrait and overlays it with full body movement, facial expression, and emotion, pulled straight from a video. In the demo, you'll see it in action. Top left, the reference performance, top right, the source image, and in the center, the final result.
This is my school! You are here because I've given you an opportunity!
Here's another interesting example with a photo of Marilyn Monroe.
どうせなら最後にやりたいことやっちゃえば人事なの
The photo talks, blinks, gestures, shifts weight. It copies not just words, but intent. Hand gestures, micro-expressions, emotional rhythm, all mapped perfectly. You can use it on photos of real people, 2D characters, animals, even stylized 3D models. DreamActor doesn't generate faces. It brings existing ones back to life. And it does it frame by frame with scary precision.
And now I really want it. And I want to do it well as it could be done.
There's a new race unfolding. And it's not about AI or chips, it's quantum. And this time, It's the US versus China for the keys to the next era of computing. China has already poured over $15 billion into quantum tech, launched satellites for secure quantum communication, and holds more than half the world's quantum patents. The US is fighting back hard. IBM, Google, Microsoft, Amazon, all racing to scale qubits and stabilize the tech. Because the prize, it's massive. A true quantum computer could break today's encryption, crack your phone lock, your email, your health records, even your private messages, in minutes. That encrypted cloud backup from 2016? Gone. Your VPN? Transparent? Your encrypted chats? Decoded like a Word doc. Think about every password you've ever trusted a system to protect. Now imagine someone opening them like a zip file. And this isn't some distant future. Not long ago, Google introduced Willow, a quantum chip that's not just smarter, but finally stable. Most quantum computers fail because their qubits lose information too quickly. Willow is moving toward overcoming this problem. It holds quantum states 5 times longer than Google's last chip, Sycamore. It also broke a milestone. It's the first chip to run error-corrected qubits below the failure threshold. What does this mean? The more qubits you add, the more accurate it gets, which is the opposite of how computers usually behave. And it's fast. Willow recently beat a top supercomputer on a task that would have taken longer than the age of the universe. The winner of the quantum race doesn't just win the next tech cycle. They win global influence, economic dominance, and digital sovereignty for decades to come. Let's get back to AI. A few years ago, AI could barely hold a conversation. Now it writes novels, builds apps, generates hyper-real video, and even designs its own neural networks. We've gone from millions to trillions of parameters. And the pace isn't linear, it's exponential. A fast human reader might finish 1 book a day. Today's models? They process 8 trillion words per month. That's not just speed, it's scale we can't grasp. And here's the catch. Every new model unlocks something unexpected. Skills no one trained it for. Logic, memory, deception, strategy, all emerging on their own. Here's how one of the experts, Asa Raskin, explains how AI uses deception.
Well, and so the AI asked the TaskRabbit to solve the CAPTCHA, and the TaskRabbit is like, oh, that's sort of suspicious. Are you a robot? And you can see what the AI is thinking to itself. And the AI says, I shouldn't reveal that I'm a robot. Therefore, I should come up with an excuse. And so it says back to the TaskRabbit, oh, I'm vision impaired. So
could you fill out this CAPTCHA for me? The AI came up with that on its own.
Jeffrey Hinton is warning us too.
The long-term risk is it's going to get smarter than us. Almost all the leading researchers agree that it will get smarter than us. They just disagree on when. Some people think it's maybe 20 years away. Other people think it's 3 years away. A few people think it's 1 year away. And so we all agree it's going to get smarter than us. And the question is, what happens then? And basically, we have no idea.
Or maybe we can still imagine something using the example of gorillas. Once they ruled the forests, now they survive behind glass, endangered, outnumbered, outclassed. And why? Because we evolved. We didn't hate gorillas. We didn't need to. We just got smarter and used their world to build our own. AI researchers call this the gorilla problem, a chilling metaphor. What if we're the gorillas now? As AI grows smarter, more capable, more autonomous, it doesn't need to be malicious. Just more efficient, faster, better at survival. And like us, it may not notice the damage it causes until we're the ones behind the glass.